This one gives a little better explanation before actually diving in about differential equations, which are what these are called. It's just the relationship between rates of change. So rates of change are slopes, and then the other values that they're equivalent to. So these are all examples of differential equations, the rate of change dy dx related to x and y, or maybe both. And so we have to separate those out. Now, when we're separating them out, this is pretty important right here. You can only separate the variables with multiplication or division. You can't add or subtract in order to separate the variables. So keep that in mind. All right, so like the example that we did in note 78, the first thing I'm going to do here is multiply by dx. So I get dy equals negative x over y dx. But I still need to get rid of that y, so now I'm going to multiply both sides by y. That will get rid of that. So I have y dy equals negative x dx. All right, so now that they're separated, I can integrate each side. And so the integral of y would be y squared over 2. The integral of negative x would be negative x squared over 2. Now, each of those would also have a plus c. But since we don't know what c is, there's no point in putting c on both sides of the equation. It's just an unknown. So for that reason, we just put the plus c on one side. Okay, so now it wanted us to find the particular solution going through 2, negative 3. So x is 2, y is negative 3, so negative 3 squared over 2 equals negative of 2 squared over 2 plus c. So we get 9 halves equals, let's see, negative 4 halves plus c, or 9 halves plus 4 halves equals c. 13 halves would be c. And so our equation would be y squared over 2 equals negative x squared over 2 plus 13 over 2. Now this one also said to find f of x. So if it did not say to find f of x or to solve for y in this function, you could leave it just like that. But because it does ask us to solve for f of x, we need to finish it out. We need to get y by itself. So I'm going to multiply everything here by 2. So we have y squared equals negative x squared plus 13. So we're going to take the square root of both sides. We have y equals plus or minus the square root of negative x squared plus 13. Now, that's two equations. Y is positive square root of negative x squared plus 13, and the negative version of that. So how do we know which one to use? Well, they gave us a point here, the point 2, negative 3. And if I put 2 in for x, then 2 squared would be 4. This would make it a negative 4. Plus 13 would be 9. And the square root of 9 would be 3, not negative 3. So that means that this positive isn't going to work for us. Our solution would only be the negative square root of negative x squared plus 13. All right. So we have several examples here. These are kind of lengthy notes, but I feel like it's a pretty good topic to have several examples for. There are going to be a lot of different types of problems. So here we go. For this one, we got ds dt equals the square root of st, or that's to the 1/2 power s to the 1/2 power t to the 1/2 power. And since we're going to have to separate them, we probably need to go ahead and give each one their own exponent. Then we're going to multiply by dt. And then we're going to divide by the s to the 1/2. So I get ds over s to the 1/2 equals t to the 1/2 dt. Okay, well, we're going to integrate that. But before we go ahead and set up our integration symbols, we might want to go ahead and bring this up as a negative exponent. S to the negative 1/2 ds equals t to the 1/2 dt. All right, so now we can see our power rule. We can use our power rule to add to that. So we add 1, and we're going to get positive 1/2 over 1/2, or just 2s to the 1/2. And over here, we're going to add 1. We get 3/2 over 3/2, or 2/3. T to the 3/2 power, and we're going to put our plus c. All right, now this one says t is 0 when s is 1. So they want us to continue and find the particular solution for t is 0 and s is 1. So we have 1 to the 1/2 power equals 2/3 times 0 to the 3/2 power plus c. So this is just going to be 2 equals c. So if c is 2, I'm going to go back right here and put that in. 2s to the 1/2 equals 2/3 t to the 3/2 plus 2. Now, this one doesn't ask us to solve for s or solve for t. What it asks us to do this time is to find s when t is 9. So the next piece to this one, now that we have the equation, is to plug in t is 9. 9 to the 3/2 power plus 2. All right, so the 3/2 power, that's the square root of 9. So that'd be 3. 3 cubed would be 27. So 2/3 times 27 plus 2. All right, 3 goes into 27 9 times. 9 times 2 is 18. So 18 plus 2 would be 20. Divide by 2. So s to the 1/2 is 10. So to solve for s, we're going to square both sides. S is 100. Okay, so sorry, you guys. See that last part there? I'll give you a minute to copy that down. It depends on what they ask you to do. In the first example that we did, they asked us to find f of x to solve for y. If they had not asked us to solve for y, we could have stopped way up here. In this one, they did not ask us to solve for a particular letter, but they did ask us to solve for s when t was 9. So we had to continue from whichever form you want. And once we had our c value, go ahead and solve for s. So just be careful about what they're asking. All right. So our next example has a natural log in it. So this is what we just finished up our last unit on. So let's see if we can talk about this y prime right here. We're used to using y prime for it to represent derivative, but remember in this situation that really means dy over dx. So we have ln of y dy dx equals y over x. All right, so we want to separate our variables. So I'm going to multiply by dx. Gets rid of that. But now I still have y over here, so I'm going to multiply both sides by 1 over y. That will get rid of that y. And so what I've got now is 1 over y ln of y, or ln of y over y. I think I'll leave it just like it is. We're going to integrate 1 over y ln of y dy, and what's left over here, 1 over x dx. Okay, so all of this was to separate the y's on one side, x's on the other. Now we're going to integrate. So hopefully you remember from our last unit, I know we haven't been in school, but if you did some of those lessons in our little test that we took, this is probably going to require u substitution. If you let u equal ln of y, du would be 1 over y. We'd have our derivative there, 1 over y dy. So this is our derivative. We have the integral of u du. Over here on the other side, we still have 1 over x dx. All right. So when I integrate u, I just get u squared over 2. 1 over x, when I integrate that, remember that's the red flag, because even if you try to bring that up, it would be x to the negative 1 power. You add 1, you get 0. X to the 0 power over 0, not possible. So remember that this one is the one where when we integrate, we go back to the natural log, ln of x. We need our plus c. All right, so plug our function back in here. This would be ln of y squared over 2 equals ln of x plus c. All right, so not the best looking equation, but it is solved. They did not ask us here to get y by itself, but what they did ask is for us to find c. They gave us a point so that we could solve for c. So we're going to go ahead and plug these in. This for x, e for y. So we'll have ln of e squared over 2 equals ln of 1 plus c. All right, so e to what power gives you e? That's just 1. And 1 squared would be 1. So this is just 1 over 2. Ln of 1 is just 0. So that makes c 1/2. So I have ln of y squared over 2 equals ln of x plus 1/2. And I guess if you didn't like this 2 in the denominator, you can multiply that equation through by 2 and just have ln of y squared equals 2 ln of x plus 1. Either one of those would be okay. So both forms are fine. They didn't ask us to solve for y, so that's it. That's as far as we need to go. All right, so example 4. This one says at each point xy on a certain curve, the slope of the curve is 3/4 y. So again, they're giving it to us in a different way. The slope of the curve means the derivative. So the derivative, this is dy dx. So we need to separate over and multiply through by dy dx. By dx. And then we're going to divide by y. So we'd have 3/4. I'm going to put the y's on the left. We would have 1 over y dy equals 3/4 dx. All right, so we want to integrate that. So the integral of 1 over y would be ln of y. The integral of 3/4 is 3/4 x. We have a plus c. All right, so it says the curve contains the point 0, 10. We want to find the equation. So x is 0 and y is 10. We have ln of 10 equals 3/4 times 0 plus c. So c is ln of 10. So we have ln of y, ln of y equals 3/4 x plus ln of 10. Now, it wanted us to find the equation, and so usually that means to solve for y. So I'm going to go ahead and solve this one for y. If I'm going to solve for y, then I'm going to probably need to rearrange this. Remember, this is log base e. So I could put e to this power equals y. The switching around, the womp womp that Mr. Krause used to talk about. So e to the 3/4 x plus ln of 10 power would equal y. Okay, so addition, remember, used to be multiplication. This is e to the 3/4 x times e to the ln 10. And we also know that if we solve this, if the base here and the base of the exponent are the same, this is just going to work out to be 10. This is just 10 times e to the 3/4 x. Or y equals 10 e to the 3/4 x power. That would be our equation. All right, I think I'm going to take a little break here and put a second video in. So we'll do this next example with a separate video.